Hello, welcome to the second part of lesson 5.2, Recalculus, Verifying Trigonometric Identities. Our learning objectives are verify trigonometric identities and determine whether equations are identities. Our first exercise is verify the following identity: sine theta minus sine theta cosine square theta equals sine cube theta. As we've seen before, we have to use one of the strategies that we talked about, whether it's factoring, combining fractions, converting everything to sine and cosine, multiplying by the conjugate. Now for this example, as you can see, we have sine and sine, so it's a good idea to use factoring. So let's just start by taking sine as a common factor, so 1 minus cosine square theta. Sine theta, 1 minus cosine is sine square theta. So sine times sine square is sine cube theta, which is what we have here. So this was a very straightforward exercise. Pause the video at any time to redo this yourself or see how it was done. Our second exercise from the textbook, number 5, cotangent square theta, cosecant square theta minus cotangent square. We want to prove that it equals cotangent for theta. Again, we can take cotangent square theta as a common factor, so we're left with cosecant square theta minus 1. Cosecant square theta equals cotangent square theta. So we have cotangent square theta times cotangent square theta. That's cotangent theta to the power 4, which is what we have here. Again, very straightforward exercise. And we did that by factoring. Let's move on to this to the next exercise. Number 6. Verify the following: tangent theta cosecant square theta minus tangent theta equals cotangent theta. Let's take tangent tan theta as a common factor. Cosecant square theta minus 1. This equals, this one is cotangent square, so it's tangent times cotangent square theta. Now tangent is 1 over cotangent, so 1 over cotangent theta, cotangent square theta. This goes out with this, so we're left with just cotan theta. And that's again what we have on the right side of the equation. Alright, pause and at any time and go over this one more time. Alright, now number 8. This is a little bit more challenging, even though it's not that hard. We have two fractions on the left side, so we're going to combine those two fractions. Now the common denominator is 1 minus cosine theta times sine theta. Okay? Cross. So sine squared theta plus 1 minus cosine theta squared equals sine squared theta plus the first one square, which is 1, minus the first times the second times 2 cosine theta, plus third one square, cosine square theta, over 1 minus cosine theta sine theta equals. So we have sine square theta plus cosine square theta plus 1 minus 2 cosine theta. 1 minus cosine theta times sine theta. These two, sine squared plus cosine squared, 1 plus 1 minus 2 cosine theta over 1 minus cosine theta times sine theta. So 2 minus 2 cosine theta, 1 minus cosine theta times sine theta. Take 2 as common, 1 minus cosine theta, 1 minus cosine theta times sine theta. These two cancel each other out, so we're left with 2 over sine theta, and as you might have guessed, this is 2 cosecant theta. And that's it. It's a little bit lengthy, but it's not that hard. Again, we use the combining fractions strategy. Alright, let's pause. Alright, let's look at number 11. 1 over 1 minus tangent square theta plus 1 over 1 minus cotangent square theta equals 1. Now if this was 1 plus, we could have said this is secant square and 1 plus cosecant square, but it's 1 minus, which makes it a little bit harder. So let's try to use to replace tangent with sine over cosine and cotangent cosine over sine. So it's 1 over 1 minus sine squared theta over cosine squared theta plus 1 over 1 minus cosine squared theta over sine squared theta. Let's add each denominator. So it's 1 over, now right here the common denominator is cosine squared theta, cosine squared theta minus sine squared theta plus 1 over sine squared theta so it's sine squared theta minus cosine squared theta equals. Now we have 1 over this, so we can flip that. I think we can say cosine squared theta over cosine squared theta minus sine squared theta plus sine squared theta over sine squared theta minus cosine squared theta. Now these two denominators are the opposite of each other, so we can replace this, we can multiply this by minus and minus, which makes it cosine squared theta over cosine squared theta minus sine squared theta minus sine squared theta over cosine squared theta minus sine squared theta. We have a common denominator here, which is cosine squared theta minus sine squared theta, and right here cosine squared theta minus sine squared theta. Now both the denominator and numerator are the same, so the answer is 1, which is what we're supposed to get anyway. Alright? Please pause and go over this one more time. Alright, let's do one more exercise. Cosecant theta minus cotangent theta multiplied by cosecant theta plus cotangent theta equals 1. Okay? Now, as you can see, this is like a minus b times a plus b, which usually equals a squared minus b squared. So this will turn into cosecant square theta minus cotangent square theta. Now we know that cotangent square plus 1 equals cosecant square. So bring this here, minus cotangent square will equal 1. So this one equals 1, which is what we're supposed to get. Okay? So, to recap, we did some exercises on verifying trigonometric identities using different strategies. We started with like 3 examples on factoring, taking a common factor, and then we did an example on replacing everything with sine and cosine. And right here we expanded the brackets using difference of 2 squares, and I think we've used Pythagorean identities. So anyway, different exercises, you can use different Pythagorean identities or reciprocal, or you can use any identity that you think is fit for that exercise. At the end, you're going to get the same result. Some of them are easier than others. Some of them are harder. Bottom line is you have to keep trying. And with more exercises that you do, the more experience you get, and the easier the problems will seem to you. Okay? We're done for the day. Please stay safe. Watch the videos, subscribe, leave some comments, and we'll see you in the next video, hopefully soon. Alright, bye.